Scott's Geography Notebook. Do you want to try saying it?
Da, da, da.
Another characteristic that we want to talk about in regards to the light in our atmosphere is refraction. Now, we say refraction because we want to sound very scientific-y, but refraction is just bending of the light. Okay? As light comes through our atmosphere, it's going to potentially be bent. Okay? Now, there are a number of things that can bend light energy, and a lot of that difference has to do with the density of the substance. Okay? So one example that we really see a lot is going to be that cup of water. So let's say that we've got our glass of water here, and it's a glass. We have the water surface right there, and we put our straw, paper straw, of course, because we're environmental. We put our paper straw in there, and so what we're going to start to see is that paper straw comes down, and when it reaches there, it actually starts to bend. See, the water and the air is transmitting, we'll talk about that in just a second, the light energy and the water. Well, the water has a very different density. Right? And this is a really clear example when we're looking at air and water, obviously different density. But one thing that we've learned through our other studies is that different temperatures of air can have different density as well. Right? So let's talk about one of those terms that I threw out there just a moment ago, the transmission. It's not necessarily the same as the transmission in your car, although the transmission does transfer the energy from the engine to the drive system, to the tires and axle and all that other fun stuff. But in this case, what we're talking about is we're talking about transmission, or the movement of energy. And in this case, we're talking about light. So I'm just going to put that in light energy through any material, right? Any space, anything else like that. So through a substance, through material. We'll just say through material. And the rate of that transmission is going to be dependent on the density. Okay? So that density of a substance, the density of the material will impact the transmission. Okay, so this is really nice and clear here. So we have the light energy is coming and hitting my beautiful pink straw. It is bouncing off that pink straw through the air, and I see it in one spot, and then the water density is going to be different. So it looks like that straw is bending. We see the same thing, like if you're ever cleaning out a swimming pool, you put that pole down in the water to vacuum out the bottom. And depending on where you are and how the light is hitting everything, it might look like that pole is actually bending there at the surface as well. Okay. So does this happen in our atmosphere? Oh boy, does it ever. There are a lot of great examples of bending light energy. And I want to talk about a few different ones. Some of them we're going to be just having the light bend. Sometimes we're going to be bending, but not all the bending is going to be the same. It's going to, again, break apart that white light into the color spectrum and start messing with different things. Okay, but let's talk about one example that we have. It's a night sky, and so here we'll do our horizon. Looking for the black pen. Good, we're going to do our horizon in black, and oh sure, we'll do a few trees in the distance, right? And then you have the beautiful blue sky. Well, what we are going to find are the stars that are closer to the horizon actually are sending the same light for the stars. Yes, I know they're not pink, but what other color am I going to use? Okay, the same stars that are there at higher up in the sky, but the ones that are closer to the horizon actually have more atmosphere that light is going through. And so if we could look at the sideways, here is the surface of the Earth, and way out there are the light coming from those stars. They're coming through, but there is a little bit more atmosphere when they're closer to the horizon that light energy goes through. As it goes through the different layers in the atmosphere, it's going to be different temperatures. See if I can get a thinner pen here. So different temperature layers through the atmosphere. And so what it's going to actually start to do is bend and modify the light that's coming from these. And so what we're going to see is these guys closer to the horizon are going to be twinkling a little bit more. It's as if they're shimmering, if they're turning on and off a little bit more as that light goes through the different heat layers. So one thing that we see, an example of bending of the light or refraction, is going to be twinkling stars. Will the ones up higher twinkle potentially? Yes. Are we going to see it as much as the ones on the horizon? No. Are we going to have a lot of other city lights that are interrupting the lights down here on the horizon? We probably will, and that's going to make it hard to see those. So when you're out in the desert or in the mountains away from people, take a look and see if you can tell that these stars are twinkling just a little bit more out on the horizon. The other thing that we start to see, it has to do a little bit with diffusion and refraction, with scattering and with bending, but that's going to be twilight. Right? So again, I think it would be beneficial for us to have our curved Earth. And during the daylight, during the day, right, we're going to have the sun coming through, and it's going to be coming down, maybe not directly above us, but at a much higher angle. However, and here, I'll draw us right here. Whoop, 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 whoop. And we're happy to be out in the sunshine. But of course, we've worn sunscreen and a little hat, because we don't want to burn the top of our head because we're going bald. Maybe that's just wispy hair. Oh, look, wispy hair again. Okay, and then we have the light once it goes down below the horizon. Now, what should happen, right? The sun is up in the sky and we can see it, cool. But once the sun goes below the horizon, shouldn't it all get dark? Right? Well, okay, kind of, right? So here we are, boom, 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 and I'm just going to put it down over here, right? So the sun's over here. The sun is actually below the horizon. So that light that's coming from there, we don't see the actual sun, but it's not dark yet. Okay? It's still light outside. We call that twilight, and it has to do with this layer of atmosphere. Right? Atmosphere. Good. So that layer of atmosphere is actually taking two different things. It is going to be bending a little bit of that light, but it's also scattering some of the light. So we talked in another video about the oxygen and the nitrogen that are there in the atmosphere, and that's going to be grabbing that light that might be hitting it. Right? Remember that this light, this atmosphere over here is going to be hit. It's actually going to be bending some of that light energy so that it continues to illuminate the atmosphere. So that it continues, oh, you can't see yellow very well. So that it continues to add some light here to the atmosphere. And of course, it's blue sky a little bit, and then we start to get the other colors. But that twilight that we see is going to be because of our bending of the light. Okay? We can't necessarily see it, but the sky still has color because it's bending. So we call this other example twilight. All right, and then one other way that we see light bending, and usually it's going to stay all together when it's doing this particular light bending, but that's going to be when we see a mirage. Right? Now, I made fun of a kid one time in elementary school because he came back after the weekend and he said, I saw a real mirage. And, me being sarcastic said, oh, you saw a lake? No, he saw a real mirage. He was out there driving in the desert down the lonely highway. And you're driving along there, and here we'll get the red sports car. Oh, we'll even drive on the wrong side of the road because we're rebels like that, I guess. I don't know. And we'll need the windshield. Pens are flying. Okay, there's the windshield, and we got the convertible, and oh, there's tire number 1, tire number 2. Okay, and what do we see out over there on the horizon? It looks so weird because it's like blue going across this road. Whoa. What is happening? Okay, well, we know that the light energy is coming from the sun. Okay? That's good. And we know that the sky is going to be blue. But here's what's happening. Let's take this and we'll make it flat. We got to make another little drawing up above here. If we draw our cool little car, okay, and we're in the car and we're happy. We're a little bit higher in the car. Good. And we're happy. What's going to be happening is we have heat radiating off of the surface. Okay, this is going to be different density. Oh, density. So what is happening is the light energy is coming, and we have a blue sky, potentially, right up there. We can also see the mirages where they actually look like they're starting to bend, like even trees or mountains out there over the horizon. But let's just take that blue sky, and the light obviously is emanating in multiple directions. Okay? We see blue sky when we're over here in the car. Wait, it's not bending yet. I think my hand's hitting the paper. Blue sky, good. All right, but what's also happening is the blue sky is hitting this heat down here, and that is actually bending the light so that when we look at the road further ahead, we see what looks like a reflection there on the ground. Okay? We get closer and it goes away. Okay? If we're out there in the middle of the desert and our clothes are all tattered, we're crawling along in the sand and we see that really warm spot out there, it's going to look like water's out there on the surface, and we're looking for that, but it's not there. Okay? This bending of the light from heat, actually making it look like there's like this little oasis out there, or at least water across the highway. This is called a mirage. Okay. So we see twinkling stars, we see twilight, we see mirages. This is all things that our atmosphere is doing with the light that it has to bend it and to shape it a little bit more. Okay? There are other examples of refraction where it really actually starts to scatter apart the light, and we'll get into that in a different video.